Okay, cool. Let's start then. So, today we have our next talk on the space mission series. It's been quite a journey so far. Today we have Hitesh and Sankalp from BSMS 2021. They'll be giving a talk on Mangalyaan or the Mars Orbiter mission today. So, yeah, good luck to you guys and hope you all have a great time.
Thank you, Celestic, for giving me this opportunity to be here. Okay, hello people, welcome to our presentation. Uh, I am Sankalp, and me and my friend Hitesh are going to give a presentation on the MOM mission, which was conducted by ISRO. So, before starting the presentation, I will love to ask you guys a question. Like, why do you think this mission was important to conduct? Like, what is the why is this information? Why is this mission more important than other mission? And why is it more famous than other mission? What's the speciality of this mission? You think so? What's more special about this mission? Am I audible?
Yes, yes, you are.
Lowest budget mission from
Yeah,
India.
yeah. So why do you think this mission is quite special than any other mission which was conducted by ISRO? Anyone?
That's because we are the first country to reach Mars.
First country of Asia to reach Mars in our maiden attempt. In the first attempt, India is the first Asian country to do so. So yeah, let's start. I will give you a brief introduction about it, a small introduction. Okay. So yeah, Arshna, you were right. India, the Mars mission has been a great success for India because it was India's first interplanetary mission, and India has been successful in this mission in its first attempt. Like no country in this world have been successful in its first attempt, and India is the first Asian country to conduct this interplanetary mission. And yeah, this mission took a lot of efforts, and we can't even imagine the amount of intelligence and the zeal which was put behind this mission by the scientists of India. And sometimes, like even in our calculation, like while doing calculation in physics, we take the gravitational acceleration as 10 instead of 9.8. But here in this mission they can't do so because they required a lot of accuracy and precision. So we need to this presentation is to appreciate, or is to give them a tribute. So it's our duty as a citizen of India to give these scientists a tribute for what they have done and what they have conducted the mission. So yeah, before going to the details of the mission, I will like to provide you a few basic information about this mission. Okay, so this mission was launched on 5th November 2013. Although this mission was launched on 2013, but this was announced 5 years earlier by G. Madhavan Nair, the then chairman of ISRO. So this mission was announced on 23rd November 2008. Like 5 years earlier, this mission was announced. And yeah, so after conducting this mission, the Mars orbiter reached the orbit of Mars on 24th September 2014, and it's still operating to this day. Like we never imagined that this mission could go even after 6 months, because scientists thought that this mission will be a fail after 6 months, but this mission is still operating to this day. Although few of the parts of Mangalyaan has stopped functioning according to the reports from ISRO, but the payload, like the Mars color camera, is still functioning, and we are still receiving data from the camera yet, and we are still receiving the images from the Mars color camera. So yeah, and ISRO is the fourth space agency after Roscosmos, NASA, and European Space Agency. And we all know Roscosmos is the space agency of Russia, NASA is the space agency of America, and yeah, European Space Agency is the space agency of Europe. and the first Asian country to send a spacecraft into the Mars orbit in its maiden attempt, in its first attempt. So yeah, it's a big achievement for us. And yeah, this spacecraft is now currently being monitored by the ISTRAC, the ISTRAC, which is the ISRO Telemetry Tracking and Command Network, and the IDSN, the Indian Deep Space Network. Okay, so these are just these are used to locate the satellite and to collect information regarding the Mars from the satellite. And my friend Hitesh will explain it in the future slides ahead. So yeah, this was the basic information about the the mission, and now let's move to the objectives. So yeah, okay, so yeah, before moving ahead, I would also like to ask you, like, why do you think is it necessary to study about Mars? Like, why is it necessary to study about it? Like, why are we conducting all these things? Like, what are we getting benefited about it? Like, are we getting benefited by studying Mars? Hello, anybody? Like, why do you think, like, are we getting benefited by this mission by any ways?
We are trying to find lives on Mars.
Yeah, exactly. So yeah, that's true. That's again one of the biggest science mystery. Although it is considered as science fiction yet, but we never know that fiction may get converted into non-fiction soon. Yeah, that's true. We are finding life on other another planet, and we also know that there is a lot of space race which is going on right now. Especially people like Elon Musk are now promoting it a lot more right now. Even Elon Musk is planning to colonize Mars in the upcoming future. So yeah, people are now getting a lot of people are getting aware of this space colonization part, and every country, like everyone is trying to dominate the space race. So yeah, India is also participating in this space race. So yeah, the objective behind conducting all this mission was to to be ahead in this space race, and to be at par of other nations, and to prove the worth of our country and to dominate the space race. Yeah, so the technical objectives of this mission, was to design and realization of Mars orbiter, which means to send the satellite into the Mars to study about Mars, and to make the satellite orbit around the Mars to collect information about it, and to navigate, or to for future studies too, we will get the data from the Mangalyaan for the future studies of Mars. So these were the technical objectives. It was just to launch satellite and to collect information about it. What kind of information, I will talk about it later. So yeah, so these were the technical objectives. Now let's move to the scientific objectives. So yeah, okay. Now let's say you want to construct a building, on a place, on a land. So what factors you will consider? Okay, so before colonizing any planet, so what kind of factors you will consider to colonize it? Anyone? Like, if you want to build or construct something, construct anything on the Mars, so what are the things that you will study before constructing anything on it? Anybody? Oh,
Gravitational force?
yeah, gravitation force, even that's necessary, but don't you think that soil is also important? Studying about the soil or the topology is the even Mars has many mountains and valleys. So yeah, studying about them is also important, because we never know like when it is required, because we may colonize it in future. So yeah, studying about the topology is also important. And yeah, again, that the point that you added in the earlier slide, that the evidence of life on Mars was also one of its objective. So like, is Mars sustainable planet? That's also one of the great question that can be asked. So yeah, the one of the objective was also to study if Mars is a habitable planet or not. And yeah, let's see what we'll get, what kind of information we get from this in future, because the mission is still going on, as I said. So yeah, so, and again, for I'm just sharing a fact here. As I said, topology. Mars also has the, you know, the largest, the highest peak in the whole universe. Do you know the name of the mountain which is the highest peak of the whole universe? No, it's not Mount Everest. It's Mount Olympus. Mount Olympus is a mountain on Mars which is 3 times higher than Mount Everest. So yeah, it's just a fact that I wanted to share you, an interesting fact. So yeah, so let's move to the next, the design part of the satellite. So yeah, so before launching any satellite, we first plan like how the satellite should be made, and what all things are required, to study about it after objectives. See, because when we have to conduct anything, whether it be any plan or any mission, we first we should first know like what things are required or what instruments are required to study about a particular thing. So according to that, we design our satellite, right? So yeah, so these are just a few factual things that I'm going to share with you. The lift of mass, the the lift of mass is actually the mass which is propelled into space. So it was around 1337.2 kg plus 852 kg. 852 kg is the propellant mass. So can anyone tell me what propellant is? Anybody?
It's the fuel, right?
Yeah, it's the fuel which is used to propel spacecraft into space. Yeah, correct, Rashmi. So yeah, now bus. Now coming to bus. Now what exactly is a bus? Bus is something, type of carrier vehicle, you can say, which carries payload with it. Payload are all the required instrument to carry out experimentation and to study a particular thing. So bus carries all those payloads. So bus is a really important part of design because it will carry all your instrument which is required to study about Mars. So yeah, now it is the I1K structure. So no need to worry about it. I1K structure. I means the INSAT. INSAT means the Indian satellite, and 1K. The K stands for thousand. Okay. So 1K, it's INSAT 1000 structure, which is the name of the structure through which it is designed. And so the structure and the hardware. The hardware is the propulsion which was used is similar to Chandrayaan 1. In fact, this mission was planned, while Chandrayaan 1 was launched. So, you can say that scientists are improving their ability to launch vehicles into space. So, yeah, this was the modified version of Chandrayaan 1. That's it. And next is the power part of the design. Okay, so how does the, Mangalyaan gets its power from it, the energy from? So there are 3 solar panels which are placed into the satellite. Each one has a dimension of around 1.8 into 1.4 meters, and it can collect a maximum of 840 watts of power generation. And that electricity is stored inside a lithium ion battery of 36 ampere hour. Ampere hour is the unit which is used for a battery. And yeah, and now comes the propulsion part. Again, the propulsion is used, to propulsion are actually thrusters which helps us to shoot the satellite into further orbits or to orient the satellite into correct position, because orientation is also important by studying anything. Because let's say you have a telescope and you want to study moon, so you need to orient the telescope in the right way to study the moon, right? You can't point at random star and say that, oh, so this is moon. You can't say. You need to study by orienting the instrument in a proper direction. So the satellite also had few thrusters which help the satellite to orient themselves with respect to with respect to their function that they wanted to do. So yeah, one of its thruster was the 440 Newton thruster, which used a liquid fuel engine, which was used to raise the orbit. Like, okay, so this mission was conducted from various stages. One of the stages was the orbit maneuvering that my friend Hitesh will explain in further slides. So what it does was like it just propels the satellite from one orbit to the another. In short, increases its altitude. So yeah, so one of the thruster, which is the 440 Newton thruster, help the satellite to raise the orbit of the satellite and to insertion of that satellite into the Mars orbit. And it also had 8 thrusters, 22 Newton of thrusters, which helped it to orient itself in the right direction to study about Mars as well. And also it also had few things like this system of maneuvering, the altitude and orbit control system. Let's come to the second last point. Now, system of maneuvering is again the I will explain, like my friend Hitesh will explain maneuvering exactly what is it in the future. So yeah, maneuvering is actually raising the orbit or to orient it correctly. So that's what maneuvering is. To carefully send the satellite into space or to orient it in the right orbit is what is called as maneuvering. There are various types of maneuvering, and it requires various type of instruments and systems. So those group of instruments which help the satellite to maneuver is called the system for maneuvering. There are various stage of maneuvering which my friend Hitesh will explain in the further slides. Now, two star sensors and a solar panel sun sensor and post analog sun sensor. Okay, so these three words I will explain you. So these sensors actually were used to detect the position of stars or sun with respect to that vehicle. Okay, so why do you think, like, why is it necessary to also study the position of star with respect to that vehicle? We are sending the satellite to Mars, right? So what was the need of to study or to have a look onto other stars around the planet? Why do you think so? Anyone? Why was it necessary to keep an eye on other stars? Anyone? Okay, no issue. So yeah, so these the coarse analog sun sensor was used to locate the position of sun with respect to that satellite. So yeah, so this used to give us a proper position of that satellite too, because see, in the solar system, sun is generally used as a reference point through which you can locate each and every planet or any satellite which is roaming around. So the coarse analog sun sensor does not always it also used to give you the correct position about the Mangalyaan, and it also had the four reaction wheels and primary propulsion system which used to orient the satellite into the right orbit again. So it was also useful for maneuvering. Now comes the last part of design, which is the antenna part. Okay, so there were three antennas: the low gain antenna, mid gain antenna, and high gain antenna. Okay, now I will explain what these antennas exactly were. So yeah, the low gain antenna. Low gain antenna are generally called as the naked eye of the satellite. Okay, so they low gain antenna were used to study the visible light which were in the planet's atmosphere, and therefore it is called the naked eye, because we are able to only see the visible light, right? We can't see the UV rays or IR rays. And so to study other ways like IR waves or UV rays, we need other antennas like the mid gain antenna and high gain antenna, which can be used to study other waves like IR and UV. And the high gain antenna used to send the data to us by amplifying the waves and all those stuff. So yeah, any question that you have in the design part, like it's quite factual, but anything, anyone? Okay, so no problem. We'll move to the next slide, the payload part. Yeah. Okay, so again, what exactly payload is? Like, can anyone tell me what payload is? I just explained in the second or third slide. I don't remember. Like a few minutes ago, I explained what payload is. So can anyone tell me? Anyone? Okay, so payload is the instrument which is carried by the satellite into space to study about the characteristic about that planets, and it and payload are the really important instrument which is required to study. So one of the payload is the Lyman alpha photometer. So Lyman alpha photometer is used to estimate the D by H ratio. So D by H ratio is nothing. So D stands for deuterium and H stands for hydrogen. So okay, now let me ask you one more question. Like, why do you think, like, is it necessary to study the amount of hydrogen in the atmosphere of Mars? Why do you think? Why is it necessary to study the amount of hydrogen in the Mars atmosphere? Anyone? Okay, so no problem. Okay, so this was because see, by studying the d by h ratio, we may also get the the and rough assumption about the amount of water which was present on the Mars surface, because again the hydrogen which escapes the planet to the atmosphere is the same water which is the same hydrogen which is in the form of water into that planet. So it also gives us a rough assumption about the amount of water into that planet. So and as pointed out earlier, this mission also had a objective of studying the life on Mars. So studying the amount of water on that particular planet is also important. And to study about it, we need to study about the hydrogen ratio, the D by H, the deuterium upon hydrogen ratio. So yeah, it also estimates the escape flux of H2 corona. H2 corona is nothing but just the cloud of hydrogen gas which generally escapes into space due to various reasons. Due to because see, the atmosphere is also divided into two parts. One is the exosphere and the exobase. Exobase is the part where is a part of the atmosphere where the particles have a lot of collision frequency, and exosphere is the the highest part of atmosphere where the collision frequency of atom is too low, because of which a few hydrogen molecules are just thrown out of into the space, thrown out of the atmosphere. So yeah, it also so the Lyman alpha photometer collects the information and analyzes it to get the rough assumption of the amount of water which is present on that planet. Just it just gives a rough assumption about it. Okay, so yeah, this was the Lyman alpha photometer. Next, let's move to the next payload. So yeah, this is the methane sensor of Mars, also called as the MSM. Okay, now this MSM was launched by the objective to study the amount of methane in the atmosphere of Mars, but due to a design flaw, we were not able to study it. Instead, it was repurposed as an albedo mapper. Now, I will tell you what albedo mapper exactly is. Okay, so albedo mapper is used to study the amount of light reflected from the surface of the planet. So yeah, that's what albedo mapper does. It just collects the light which is reflected by that planet. In short, it studies the reflectivity of the surface of that particular planet. That's it. So yeah, this was the function of the MSM, the Mars sensor, the methane sensor of Mars. So yeah, now let's move to the next payload. Okay, so this is MENCA, the Mars Exospheric Neutral Composition Analyzer. Okay, so can anyone tell me what Mars Analyzer exactly is? Okay, so no issue. Can anyone tell me what mass spectroscopy is? Because I don't expect anyone to know what exactly mass analyzer is, but mass spectroscopy, anyone? This concept was, I think, so in our high school probably. Anyone? Can anyone tell me what mass spectroscopy exactly is? Any assumption? Anything? It's fine. Okay, nobody. Okay, it's fine. So mass spectroscopy is used to study the mass by charge ratio of ions. So the quadruple mass analyzer is nothing but it is the same thing. It is the quadruple mass spectrometer which is used for mass spectrometry. Like it just collects the amount of is composition of particles from the atmosphere of Mars, and then pass those particles through a series of four rods. Those four rods are generally connected in parallel to each other, and what it does, it sends an oscillating electric field which separates that particle with respect to their charge by mass by charge ratio, through which we are able to separate particles and study each and every particle separately. So yeah, even this was one of the most important part of the payload because it helped us to study about the amount of gases or the amount of element which are present inside the atmosphere of Mars. So yeah, now let's move to the next one, which is the thermal infrared imaging spectrometer. Okay, so yeah, thermal imaging spectrometer was used to study the surface image of Mars, and it was able to operate both day and night, and it is also used to study the mineralogy of Mars. Can anyone tell me what exactly mineralogy is? Anybody? What exactly is mineralogy? Okay, it's fine. Mineralogy is the study of the amount of mineral present inside the soil of that particular planet. So yeah, even this was one of the most important instrument because it gives us the important minerals which were present inside the Mars surface, which will also give us the rough assumption of the number of the rough assumption about the life which are present on Mars. So yeah, and it is also used to study the emissivity. Emissivity is the so we have studied emissivity. We all know about the Stephen Boltzmann constant, right? We have studied about it in our 12th standard. So emissivity is the ratio of energy radiated to the energy radiated from a black body. So yeah, and it is also used to study the turbidity of Mars. Turbidity is nothing but the uh, the amount of gas which are present in the atmosphere and the opacity of that gas. That's it. So it is used to study the temperature, emissivity, and the turbidity, and also the amount of minerals which are present inside the surface of Mars. Now, let's move to our next payload, which is the MCC, the Mars Color Camera. Again, one of also the important part. Okay, so MCC was used to take images of the Mars, and it was generally used like a CCTV camera. Like we like using MCC, we not only studied Mars, but we also studied the neighboring satellites of Mars. The natural satellite of Mars. The name of these are given in the slides, which are Phobos and Deimos, which are the natural satellite of Mars, and also we used it like a CCTV to monitor Mars. Like Mars also has many dust storms and all the stuff which are going into the planet. So to it was used to monitor the Mars in short. And yeah, that's all about Mars color camera. So most of the information and Mars color camera is the only thing which is now functioning in the satellite. Most of the payload has now stopped functioning because it was only this mission was only for 6 months, but it extended up to 8 years, which is a quite fascinating thing. And now Mars color camera is still functioning, and it is still sending us the data, and is still sending us the photos of Mars. And the photo that you see in the slide, the photo of this Mars is the first photo which was clicked by the MCC. So yeah, that's what about the payload. And next, go to the next part. So I will like to hand over the mic to Hitesh, and will tell Hitesh to take the charge from here.
Yeah, hello guys. I'm audible?
You are audible, Hitesh.
Yeah, thank you. Uh, Welcome to the part of telemetry and command. And as Sankalp said, after the payload, it's very important to know about the telemetry and command and how they control that spacecraft and how they launch it. So now we are about to know how did they do that. Uh, the navigation operations of the M- Mangalyaan were controlled by Telemetry and Command network of ISRO. Uh, they are, I mean, they are controlled from Sriharikota, Port Blair, and Brunei and Biak of Indonesia. And even Indonesia helped us in Mangalyaan. So thanks to them. And here, the apogee of the spacecraft is more than 1 lakh kilometer. I hope you know the meaning of apogee, the farthest point between the sun. I mean, the farthest point between an orbit from the body. And because of this, because of this long apogee, there are uh, two antenna which are used. That is 18-meter antenna and 32-meter antenna from the in which are from Indian Deep Space Network. Do any of you know what's Indian Deep Space Network? Any of you? Okay, right. Uh, Indian Deep Space Network is a network of large antennas and communication facilities that is operated by the ISRO to support interplanetary spacecraft missions of India. And as you can see there, the 18-meter dish antenna was used for communication until April 2014. And after April, the larger 32-meter antenna was used. And even NASA's Deep Space Network and South African's National Space Agency helped us in providing the satellites tracking and telemetry command service when during the non-visible period of ISRO's network. As you know that every time is in every moment ISRO can't watch this, and there will be some moments when we can lost the connections with Mangalyaan. At these moments, these NASA and South African national space agencies help us. And two 230-watt traveling wave tubes and two coherent transponders handle communications in from Mangalyaan. You may get a doubt here. What is TWTA? TWTA means traveling wave tubes. These are the special vacuum tubes which are used in electronics to amplify radio frequency signals into microwave range. And these tubes belong to the linear beam tube category. And coherent transponders offers scalability and ease of operations. They have the simpler network efficiency and remote automated wavelength turn-up and service progressions. And coming to the next slide, we have three antennas in this, as Sankalp said. They are low gain antenna, mid gain antenna, and high gain antenna. Here, if we discuss about high gain antenna, it's based on 2.2-meter reflector illuminated by a feed of S-band, and it is used in transmitting and receiving the telemetry, tracking, commanding, and data to and from Indian Deep Space Network. And there are three main phases in the mission's launch. There are four main phases in the mission's launch. That is, the first one is orbit raising maneuvers. That is, raising the orbit very carefully. Second is trans-Mars injection. As the name suggests, it's the injection from Earth's orbit to Mars orbit. And third stage is trajectory correction maneuvers. That is the correction of trajectory path of Mangalyaan. And the fourth one is Mars in orbit insertion, to insert the Mangalyaan in Mars orbit. Let's discuss about each of them in detail. Coming to the launch part, they have first thought to do with GSLV. That is, any one of you know what's GSLV? Okay, fine. It's geosynchronous satellite launch vehicle, a high powerful vehicle. But GSLV failed twice in 2010 and still had issues with its cryogenic engine. So ISRO decided to go with PSLV, that is Polar Satellite Launch Vehicle, although it's less powerful one because it would delay for 3 years for waiting for the new batch of rockets and it would increase the cost. Uh, Normally, JSLV is a powerful engine and it's an it's powerful enough to place Mars orbiter mission on a direct to transfer Mars trajectory. But PSLV can't do that because it's a bit less powerful engine comparing to GSLV. So they decided to launch in a specific way, that is into a highly elliptical Earth orbit and used its own thrusters over multiple perigee belts. Here, perigee means the nearest point uh, in the orbit of some uh, body and its satellite. And they used this trick, to place itself in a trans-Mars trajectory. Here, our scientists took the advantage of Oberth effect. Now you may confuse what's Oberth effect. Its Oberth effect is an effect in which a spacecraft falls into a gravitational well and then uses its engine to further accelerate as it is falling. Like this effect is a more efficient way to gain kinetic energy and it's more good for these less powerful engines when used. And as we know from the basic information, it was launched on 5th November 2013 and PSLV-40 placed the satellite into Earth's orbit with a perigee of 264 km and apogee of 23,903 km at an inclination of 19.2 degrees with both the antenna and three sections of solar panel arrays deployed. Now coming to the orbit raising maneuvers. During the first three orbit raising operations, the spacecraft systems were progressively tested. And here orbiter's dry mass is 475 kg and carried 852 kgs of fuel at launch. Its main engine uses the biopropellant combination of monomethyl hydrazine and dinitrogen tetroxide to achieve the thrust necessary for escape velocity from Earth. Can anyone of you say what's the escape velocity from Earth? The value of it? Any? Okay, it's 11.2 kilometer per second. And this biopropellant combination is also used to slow down the probe for Mars orbit, like to slow down the probe for Mars orbit insertion and subsequently for orbit corrections. As Sankalp said, here maneuvers means moving carefully, and orbit raising maneuvers means carefully raising the orbits. And several orbit raising operations were conducted from the spacecraft control center at ISRO Telemetry Tracking and Command Network, which is located in Bangalore on 6 days of November. That is, those are 6th, 7th, 8th, 10th, 12th, and 16th, respectively. They used the spacecraft's onboard propulsion system and a series of perigee burns. Here, the interesting one is the first three of the five planned orbit raising maneuvers were completed with nominal results, while the fourth one was only partially successful. However, the subsequent supplementary maneuver raised the orbit to the intended altitude, which is aimed in the before fourth one. But that's the only minus point which had occurred in the Mangalyaan. And these six perigee burns were occurred when while the spacecraft remained in Earth's orbit, and the seventh perigee burn occurred in the heliocentric orbit insertion of Mars. In the heliocentric orbit insertion of Mars orbiter mission for its transit to Mars. In the first orbit raising maneuver, the 440 Newton liquid engine was burned for 416 seconds, and the apogee is raised to 28,825 km with a perigee of 252 km. And in the second orbit raising maneuver, it was burned for 570 seconds, and the apogee resulted in increase of 40,186 km. And the third orbit raising maneuver was done for 707 seconds, which resulted in apogee of 71,636 km. Now the interesting fourth one, which is done on 10th November 2013, it just imparted a delta V of 35 meter per second to the spacecraft instead of the planned 135 meter per second. It means it has reduced nearly 100 meter per second speed due to the underburn by the motor. Here you may get a doubt, what's delta V? Here delta V is not the change in velocity, but it's the impulse per unit of spacecraft's mass. And because of this, the apogee was boosted to 78,276 kilometers and instead of planned 1 lakh kilometers. Like it's nearly less than 22,000 kilometers. This happened because then the testing of redundances here redundances means the state of being not or no longer useful according to Oxford. As Sankalp said in before, there are some unuseful parts like which are already used in the Mangalyaan, and because of them, our scientists thought that it would work only for 6 months, but luckily it worked for from 8 years. And while checking these parts in the propulsion system, the flow to the liquid engine stopped, with consequent reduction in incremental velocity. During the fourth orbit burn, our scientists had energized the primary and reductant coils of the solenoid flow control valve, which is a 440 Newton liquid engine, and logic for thrust augmentation by the altitude control thrusters which were being tested. And when these both primary and reductant coils were energized together during the planned modes, the flow to the liquid engine stopped. Operating both the coils simultaneously is not possible for future operations. However, they could be operated independently of each other in any sequence we want. But remember, both the primary and reductant coils should not be energized together in any way. And this may be a lesson for our scientists uh, who are in charge and who are becoming in future. And because of this fourth planned burn, uh, as it was only partially successful, an additional unscheduled burn was performed on 12th, 2 days later of this, which increased the apogee to 118,000 kilometer, which is slightly higher than the originally intended one. We want only 1 lakh kilometer apogee in fourth orbit insertion, but now we have got 1 lakh 18,000 kilometer. And then in the last, the sixth orbit insertion, orbit raising maneuver, the apogee was raised to 1,92,000 kilometer. Uh, and 23-minute engine firing and after this, a 23-minute engine firing initiated the transfer of Mangalyaan away from Earth's orbit. And now it's on towards the heliocentric orbit towards Mars. Anyone can anyone say what's heliocentric orbit? Any answer? Okay. Heliocentric. Actually, there are three phases in any launch, any mission's launch. I mean, especially in Mangalyaan, there are three phases. Those are geocentric phase, heliocentric phase, and aerocentric phase. As the name suggests, here geocentric phase is escape from Earth's orbit, and geocentric phase is escape from the Earth's orbit very constantly, and the last aerocentric phase is going to the Mars orbit, and this heliocentric phase is a between from Earth's orbit to Mars orbit. Here you can see that I think in in this slide you can see this violet color one going from blue color orbit to green color orbit. Here this violet one is Mangalyaan, blue is Earth and green is Mars. This one is Sun. Hope you see that. And now we have uh, now the probe has nearly covered a distance of 780 million kilometers to reach Mars. Now we come to the second important topic, that is trajectory correction manual, like correction of the trajectories. Uh, Actually, our scientists planned four trajectory corrections, but only three were carried out. I mean, three were enough. Three, three were made enough. In the first one, our scientists fired the 22 Newton thrusters for 40.5 seconds. And after this event, Mangalyaan was following the design trajectory so closely that the second TCM, which is planned in April 2014, was not required. And the second one was postponed for June. And exactly after the 6 months of the TCM 1, the second one was done by firing the same 22 Newton thruster for 16 seconds. And the third trajectory correction maneuver was postponed due to arbitrary trajectory close, like it's very close to the planned trajectory. And to be honest, it was a deceleration. That is, it reduced the acceleration of Mangalyaan for 3.9 seconds, and now it's in the orbit of Mars. Now we should now we should insert. We have the only step, that's Mars orbit insertion. Actually, the plan was for insertion into Mars orbit on 24th September 2014, approximately 2 days after the arrival of NASA's Maven orbiter. I think you have heard of Maven. It's also one of the very famous project like our Mangalyaan. For NASA, it's one of the famous project. And in this step, the 440 Newton liquid apogee meter was last fired on 22nd September, like for 3.9 seconds, as we discussed earlier. It reduced the acceleration just before 41 hours before the actual orbit insertion. And on the next day, the liquid apogee motor was fired for 24 minutes, and after this event of firing liquid apogee meter, the spacecraft performed a reverse maneuver to reorient from its deceleration zone and entered Martian orbit. Now we successfully made the Mangalyaan enter the Martian orbit, and the orbit insertion of Mars orbiter mission in a highly elliptical orbit around Mars with a period of 72 hours 72 hours, 51 minutes, 51 seconds, with a periapsis of 421 kilometers and apopsis of 76,000 kilometers. Sorry, 77,000 kilometers nearly. And at the end of insertion, our Mangalyaan was left with like 40 kg of fuel on board, more than the 20 kg necessary for a 6-month mission. I hope now we got one of the key points why it stayed more than 8 years. Like it had left with more and more fuel than the actually needed one, and it's not the only reason, but it's one of the reason why we have got it more than 6 months. And the 28th September 2014 is one of the remarkable day in Mangalyaan's project because Mars Orbital Mission Controller that published the spacecraft first global view of Mars, and this was captured by MCC. Here, MCC is not some Melbourne Cricket Club or medical counseling committee, it's Mars Color Camera. I think, I hope Sankalp had shown you one figure. That's the first image captured by MCC, and that's the same image here I mentioned. And for this project, we have got many recognitions too from the worldwide. Even our dearest enemy, China, has referred Mangalyaan to be pride of Asia. So we can just imagine how great the project was and how successful it was. And our Mars Orbiter mission team had won US-based National Space Society's 2015's Space Pioneer Award in the Science and Engineering category. And then after the introduction of 2000 rupee note, our Indian government had to get good decision of illustrating the picture of Mangalyaan on 2000 rupee note. And the picture taken by the Mangalyaan was a cover photo of 2016 November issue of National Geographic magazine for their story Mars Race to the Red Planet. And not only this, even we had a follow-up mission for this Mangalyaan, that's Mangalyaan 2 or Mars Orbiter Mission 2. And I hope it should be also successful, and not only I, even all the country hopes. I think I know that. I guess it will be also successful and gain uh, become the successor of Mangalyaan. And the fun fact is, our scientists had made the whole project nearly in 450 to 475 crores rupees, which is even less than the movie 2.0. I mean, it's much less than the many Hollywood movies, and even it's much less than the movie 2.0 and Triple R's budgets. Like less than a movie budget, our scientists had made India much proud by sending the Mangalyaan, and those successful people behind the mission were now shown on screen, like K. Radhakrishnan ji, S. Ramakrishnan ji, P. Krishnan ji, Maumita Datta ji, Nandini Harinath and Ritu Kartal, Chandranath, MYS Prasad, and S. Arunan ji, and many others. We can't fit in the slide here. These were one of the main people. I'm sorry. These were few of the main people who were behind the success of the mission. And these were the photos of them. I don't know exactly their names, but I guess we should remember them forever. And these were some of the pictures by Mangalyaan. And even in Bollywood, Akshay Kumar sir had made a film on Mangalyaan's project, that's Mission Mangal, which is released in 2019. And as they said in the movie, हमारे दिल में भी Mars है. And thus I conclude my speech and hope that future projects of India will also be successful, in which some of us may take part. And the note is this is the first presentation in life for me and Sankalp. So if you feel any anxiety or if you make any mistake, please excuse us. And if you have any doubts, please shoot at us now.
Yeah, I have a question. Can you say again why GSLV was a failure and PSLV was able to recover it?
Yeah, actually, I don't know why GSLV was failure, but I know that it failed due to its cryogenic engine, and our scientists had recovered that fault by sending it into from PSLV as
Actually, am I audible? Yeah,
Yes.
so it was basically that the cryogenic engine of GSLV failed, and to manufacture more GSLV, we didn't have much time to manufacture or to bring more GSLV here. So they instead used PSLV because we were having a time limit for it to conduct this.
like if you have, but if you want to manufacture it and if you want to repair it, it would take some 3 years like that, which may increase in the budget like very much. So in the control of time and in the control of budget, we have sent it in PSLV by using Gopart effect.
And in
Okay,
fact,
got it.
when the mission was launched, even the time when it was launched was really important because at that moment it was something like Mars was the closest to Earth. So even if a delay of a single day may have caused a lot of damage to our mission. So
And
therefore, instead of waiting for next GSLV, they instead launched using PSLV, which was quite difficult, but they did it, and so we came balance.
and the answer for your exact question is why GSLV is a failure, right?
Yes. You
Yeah,
said it's cryogenic problem, right? Cryogenic engine.
yeah. We know that it has an issue with cryogenic engine, but sorry, I don't know why it had an issue with cryogenic engine.
Okay, thank you.
Yeah, thanks and welcome. And any doubts again?
So thank you everyone for attending this
And
session. And
thank you for bearing us this much time.
yeah,
And should I close the slide?
Yeah, hello Hitesh and Sankalp. Your talk was like really nice. You gave like a very good all round explanation of what Mangalyaan was, and your last slide was pretty good. You managed to relate to all of us how important the mission was to India and to the world itself. So, thank you for that. And if anyone has any further questions, they can go ahead with it, or I guess we can wrap it up right now.
And sorry to say this, uh, we have planned some more questions to shoot you in between, but because of time limit, we can't do that. And if we have
You
very faster, sorry for it.
If you have like any more questions also, you can post them in the WhatsApp group as well, Celestic WhatsApp group, and Hitesh and Sankalp can try to answer them there as well. Or you can even mail Celestic if you would prefer that.
Yeah, please be free and in case of any questions. But I think because of time limit, we should end the meet. Thank you for attending and bearing us, guys.
Yeah, I think we can stop the recording now.
Yeah.
I think we are done here. Thanks everyone again for attending.